Hey everyone, we are going to do a titration today. And I know that in chemistry, this is one of the things that most of my students look forward to doing. So it's kind of sad that we don't get to do this in real life, but maybe I will try to set up something for you to take home to try to use indicators and see what's going on. There'll also be an opportunity to do this virtually. But in the meantime, I'm going to show you what titration actually is. So the basis of titration is you have one thing that's known and you have one thing that's unknown. I'm just going to raise my glasses for a second. And you're going to use the thing that's known to figure out either the moles or the concentration of the thing that is unknown. So this is a Buret, this thing right here. Okay, and this down here is a stir plate, and I'll show you what a stir plate is. It's possibly the most exciting thing that students get to use. Well, I think the Buret is actually very exciting too, but students love stir plates for some reason. And here, I'll show you. So if you take a stir plate, if you take a stir bar, and you put it on a stir plate like this, and then you turn on the stir plate. You see there, it spins it around. Yeah, there we go. And so you put that right into the solution, and it spins it for you. It stirs up the solution. That is how we keep things reacting, make sure everything is mixed up well. So in this case, I'm gonna put my goggles on now. I'm gonna have a solution, an unknown solution of acid, hydrochloric acid. So this is my hydrochloric acid here. And we're going to measure a specific amount into a flask. So the way that we measure things when we do exact measurements we typically, in the simulation they use something called a volumetric pipet. Anything that's volumetric. So this one, for instance, let me give you an example, is a 4 milliliter volumetric pipette. There's no marks on it at all. So the marks are called graduations. That's why we have graduated cylinders, because they have lines on them. This is a volumetric pipette because it's got one line. And that one line tells me that if I draw up exactly to this number right here, this line, it's exactly 4 milliliters. Okay? Or 4.0, depending on the accuracy of it. They'll tell you on this one doesn't say, I don't know where it is, but 4.00 milliliters, probably. That's not enough for this titration. I couldn't find any bigger volumetric pipettes around right now, so I'm going to use a graduated pipette. But in simulation, just know that when you draw this up, you draw it up, you kind of swish it around, you rinse it out, you draw it up, and then you get right to that line. You look eye level, and you see that that's at that place. So we're going to take, instead, a graduated pipette. This one's got graduations on it, and it's got little markings. And we're going to take 10 milliliters. So this is a pipette pump. Also, another sad thing that you won't get to use until you get to probably college. You do this. So you draw this up, you just turn this thing here like this. You can see the liquids going up here. And you get to exactly 0. And you have to check it, just make sure it's exactly at that line. And then we're going to put it into a flask. So you can just push this thing to let air in. And it's going to go all in there. Okay? And then we can go ahead and push the rest of it in using the little spinner thing. Make sure that all gets in there. If that's not enough volume, you can always add some water, distilled water, because if I add water, am I actually changing the amount of the amount of acid that's in there? So that's a question that you can think about. But sometimes acids come in solid form, sometimes they come in aqueous form. And if I dissolve it in water, in different amounts of water, will that make a difference? And so think about how much how many molecules of acid are in here. So I'm gonna set that aside, and I'm gonna go to the pipette, the Buret. So this is a Buret. It's basically a very, I'll spin this around, you can see it a little bit better. It's got lots of lines on it, so lots of graduations all along the side. And the tricky thing about Burets is reading them. So we'll work on reading them because they read backwards, and so you have to kind of get used to how they read. But whenever we use a pipette, we have this thing down here. So this is like the valve, or it's called a stopcock, and we're going to rinse it out with water once. I know students find the word stopcock also funny, but you can just get it out of your system and then just be done with it. So we're gonna we're gonna go ahead, open this up, we're gonna rinse it. I'm gonna take a funnel, put it here. I'm just gonna rinse some water down it, put a waste beaker down at the bottom, okay? So you can see a waste beaker. I'm just gonna just do that, rinse once. And then I'm going to rinse it with my solution a couple times. So always, before you do a titration, you wanna make sure that the concentration of whatever's in the Buret is uniform throughout the entire thing. So this is 0.100 molar sodium hydroxide, NaOH. I'm just gonna pour a little bit in here. Okay, so just let that run through. Do that once, do it again. Ideally, I know that in the simulation you should be higher up. The Burets should be lower than eye level, but I'm not gonna step on a step stool to get up here. This is about as low as it can go. So I'm just gonna be safe, keep our goggles on at all times. And now what I'm gonna do is once after the second rinse, I'm gonna go ahead and flush it again. But this time when it's coming through, I'm going to close the stopcock. So there we go. Run it through a little bit. I'm gonna close this like that, okay? And if you do that right, you should have no bubbles in this area here. What you don't want to have is, if you have bubbles, you want to make sure you run them through and kind of tap this to get rid of the bubbles, and then close that up again, because the bubbles are going to affect what the volume you're going to read is. Once you have that set up, you're going to fill this up to a level. Okay, I'm going to put that like there, because then you can read it easier. And then we have to read the Buret. So reading the Buret, if you look at the numbers here, let me see if I can set this up. If you notice, put this behind, the numbers go backwards. So I have 62, 64, 66, 68, 70. So they read from 0 at the top to 100 at the bottom. And so when you're looking at this, you have to think, well, this line here is 62. So then as I go down, these are 0.2 graduations, 0.2 milliliter graduations. And then we can also, the other thing you gotta know is, when you see a line, whatever that decimal point is, your estimation is to the next decimal place. So if I have 62.0, 62.2, 62.4, 62.6, 62.8, and it's right on the line, 62.8, I'm gonna call that 62.80. So it's kind of hard to see, but hopefully you can see that. I know it's not the right angle, but the bottom of the meniscus is what you want to do. So you want to get right to eye level. Okay, I'm reading that. me see here. So 62.9, it's between the two lines. So I would say 62.90 is my starting volume. So I would write that down, 62.90 as my starting volume. And then I'm gonna do a titration. So what they have you do in the simulation is a quick run first. You do a fast run to kind of see where approximately the end point is. The end point is the point at which they're all reacting. And so now you're probably wondering, well, I have a clear liquid here and I have a clear liquid here. How can I tell when they're done reacting? And the way we use that is we use something called an indicator. So this is called phenolphthalein. We're gonna put about 2 to 3 drops of phenolphthalein into here. So this is my acid. I'm gonna put a couple drops in here. And what that does is, you can't see anything right now, but phenolphthalein is clear when it's in acidic solution. However, it turns pink when it is a basic solution or around neutral. Okay, so once it gets to about neutral, it'll turn pink. And that's what we're gonna look for. So we're gonna take our flask, we're gonna put our stir bar in there carefully. We're gonna go ahead and I'm gonna put some white paper underneath, okay? And so we're gonna just go ahead and I'm gonna turn on my stir bar. So the stir plate's stirring. I'll sit down here so you can see a little bit better. And I'm gonna go ahead and start, I'll put this in here. Let's go ahead and start putting this in here. So this is a fast run. You typically are going like this to see when it turns pink approximately. If you are limited on time, and you don't have time to do multiple trials, then do the slow run first. And my friend in college used to race his other friends in his lab mates and how fast they could do titrations. They would blast it through and try to add a bunch of stuff to it turned. So we're waiting to see if it turns pink, okay? I don't recommend doing that, to add a bunch of things and wait to get it changed and then add more acid to get it to change back. Not a good idea. But you want to, you want to see how we're doing here. Okay. So you can see it's starting to change a little bit. You can see a little bit of pink there. Okay, so you normally slow down. You can see that went away. So I'm going to add some more. But this is to get a rough estimate of where the endpoint is. What you don't want to have happen is to go too fast and blast through it so that you get it to turn all the way pink. And I'll show you that just so you can see it. Okay, so you get faint pink. See, that's faint pink. Is it going to disappear? Yeah, it's going to disappear a little bit, but that's okay. We can say that that's approximately where it's going to change. So what I can do right now is I'm going to turn this off so you don't have to listen to it, because it's approximately at the end point. And so right now I'm going to look at the volume. It says 93.20. Okay? So 93.20, I subtract that from my first starting point, which was 62.90. So 92.90 subtract 62. That's 92. Subtract 62.90. That's like 30 milliliters. So I know that it's going to take about 30 milliliters to do this. And now I can do it again, but I can do it more carefully when I get to about 30 milliliters. Okay? So that's what you do. You do the fast run first, and then you go ahead and you do another run, but then once you get to about 30, you do it slower. I'm just going to skip that and just go slower right now. Okay, so let me show you. So I'm going to go ahead and turn this on, and I'll show you how to do this. So once you do the first run, and then you do the next one, and now you're waiting for it to go, you take this and you go drop-wise. So you take this and slightly, you let it, see how it's dripping one at a time? Okay, so it's pink. It's like faint pink. Let's see if it stays. And that's staying. So that's okay. Then we can stop it. That's called the end point of the titration. The end point of the titration, we record the final volume. My final volume is 94.30. 94.30. I would write that down. And now I have my starting point and my end point of the volume, and then we can do calculations. What you don't want to have happen is blasting through. So let me show you what it looks like if you blast through it and you go way past the titration. And it gets really pink. It is very pretty. Yes, it is. But it's not pretty for the chemistry teacher, because you look over and they say, well, you went too far, you got to do it over again. So that's the signal of you got to do this over again. In the simulation, they go the other way. They start pink and you go clear. So you can do it either way. Go pink, go clear, or you can start clear and go pink. But then once you have all your numbers, then you do your calculations and figure out what's the stoichiometry of the moles of stuff, and the big thing to know about titrations, acid-base titrations, is at the end point, the moles of H plus always equal the moles of OH minus. The moles of acid equal the moles of base. Okay, for strong acid, strong base. All right, good luck. And if I were to do this over again, sorry, if I can't start from this little, I'd have to fill it up again. So you fill it up to whatever, take that again, start over. That's a titration.